Okay, our objective for today, I can identify the greatest common factor and least common multiple of monomials. Read together, 1, 2, 3. I will identify the greatest common factor, least common multiple of monomials. Read again, 1, 2, 3. Very good. So we already did greatest common factors. Who remembers at the beginning of the year when we did radicals, where I had you guys do like factor trees and stuff like that? You guys remember? No? All right. Well, good. So today we're going to revisit that, okay? Except for we're going to tag that along with least common multiples. Now, when you were in elementary, I think you covered GCF when you were in 3rd grade, and same thing as LCM. Except for your teachers taught those two concepts separately. Today I'm going to blend them all together, and you're going to see how we can do all that in one step, okay? And hopefully you see the connection. To do that, we're going to use something called a Venn diagram. Who's used a Venn diagram before? We've all used it, right? So to illustrate that, let me start it off by, I'm going to show you how to use a Venn diagram using Michael Jordan. It says, what do I have in common with Michael Jordan? All right, here we go. So I'm going to create a Venn diagram. Here's Michael Jordan. This is me. So then let's see. Michael Jordan is tall. Well, I'm not that tall. Michael Jordan is a professional basketball player. Well, I'm a teacher. Michael Jordan is rich. I'm not that rich. But one thing that we do have in common is that our favorite subject is mathematics. In an interview, they interviewed him, and he said that was his favorite subject. Now, for those of you that missed it, when Michael Jordan retired and came back to the NBA, won another 3 back-to-back, then retired again, he's still making a lot of money. And one of the things that he does is the fact that he knows numbers. His accountants and his lawyers don't rip him off. As you know, there's a lot of professional players out there, at least, I know a lot of them, that they earn millions of dollars when they're playing professionally, but when they retire, they end up broke because they steal from them. Or they don't know how to manage their money. And that goes because they didn't know their numbers. That's not the case with Jordan. For example, Michael Jordan, who's heard of the Nike Airs? Nike Airs, okay, well, that started with Michael Jordan. Anytime that they sell one of those, he gets royalties. Who's heard of Gatorade? Okay, Gatorade, before it became famous, it was a sports drink for the University of Florida. They're called the Gators. That's why it's called Gatorade. So after Michael Jordan endorsed it and they made a commercial, guys, have you heard the commercial? I played for you guys, didn't you? Like Mike. Huh? No, that song that, like Mike, if I could be like Mike, I want to be, no? Yeah, what? Yeah, I played it around. It's like a cartoon, right? Oh, my goodness. So anyways, you can Google it and watch it yourself. Anyways, also, he gets endorsement from that. To make a long story short, he knows his numbers, okay? But one thing I wanted to show you how I use the Venn diagram here. Look up. Notice the intersection section here. That's what we have in common. Did I write for Michael Jordan, favorite subject math, and then I write for me, favorite subject math? Did I write it twice? No, only one time. That's because that's the area that intersects. Today we're going to use the Venn diagram with the same idea, but instead of having words, we're going to have numbers in the Venn diagram. You're like, what? That's right. So you're going to see how it works, and it works really well. So with that said, here we go. You don't have to copy this, Freya. This is just to refreshing your memory on factors. We know that factors are numbers that are multiplying. Example? Yes? Not an example. Tell your neighbor why these are not factors. That's right, because they're not multiplying, right? Only those that are multiplying are called factors, and that's one of the terms that we're going to use today. The other term is multiple. A multiple is when you take the product of any amount times an integer. So, for example, 2 times 3, 6 is a multiple of 2 and 3. 8 is a multiple of 2 and 4, and so on and so forth. Yes? Okay? Tell your neighbor why these are not multiples. Okay, so it has to be a product and there's multiplication involved. Yes? All right, so with that said, copy these 5 steps only. 6 steps only. It says, step number 1, write the first 5 prime numbers at the top of your page. Find the prime factors of each number by factorizing the numbers. Start with the prime number. Step 3, draw a Venn diagram with 2 circles, 1 for each number. Step 4, write the common prime factors in the intersection area. Step 5, multiply the common prime factors to identify the greatest common factor. And number 6, multiply all prime factors to identify the least common factor. Or least common multiple. Sorry. Copy that, please. Be nice. All right, so here we go. If you notice, the first 2 steps we already did in the past. Writing your first 5 prime and factorizing your numbers by creating your factor trees. You guys remember that? All right, but the next part, the steps 3 through 6, is what I'm going to go over today. So copy this first one, example number 1. It says, what is the greatest common factor and least common multiple of 24 and 36? Let me zoom in. Copy that. What is the greatest common factor and least common multiple of 24 and 36? Let's go over this. So first things first. Step 1 says what? Write your first 5 prime. 2, 3, 5, 7, 11. So I want those handy because I want to start my factoring of each of these numbers using one of the first 5 primes. So I'm going to write 24 here and 36 over here. So start our factor tree here. Which one of these prime numbers factors into 24? 2 and 3, right? I'm going to go with the biggest one, which is 3, so it's 3 times 8. Circle the 3 because it's a prime number. We can't do anything with that. 8 is 2 times 4, and 4 is 2 times 2. All these, like this, 3, 2, 2, and 2, are called prime numbers. But as soon as I ask you to write them as factors, you need to write them like this. 3 times 2 times 2 times 2. Why are they called now prime factors? Tell your neighbor. Very good. Because they're multiplying. Let's factor 36. Which of these is the biggest prime factor? 3 times 12. Circle the 3. 3 times 4. Circle the 3. 2 times 2. These are prime numbers, but if I ask you to write them as factor, that's 3 times 3 times 2 times 2. Yes? I couldn't hear. Sorry. Okay. Huh? Boom. Okay, here we go. Good, thank you. All right, let me scoot this up a little bit. So now this is the next step. Next step, it says, once we do that, step 3 says to create 2 Venn diagrams. So here we go. Draw 1 Venn diagram for this one. For each number, our Venn diagram, each circle represents a number. Let me scoot this in a little bit. 1 Venn diagram. Here we go. This one is for 24. This one is for 36. Focus, please. So here we go. So just like I did the intro earlier with Michael Jordan and myself, and I said, what does Michael Jordan and Mr. Q have in common? Well, what they had in common was in here, right? And I only wrote it once. So what do these 2 numbers have in common? 1, 3. There it is. What else? Only 1, 2? 2 2s. These two and these two. So what do they have in common altogether? The 1, 3, and 2 2. So I'm going to write 1, 3, and 2 2s. Do I need to write it twice? No, because that's what they have in common. All right. What's left over here that did not have in common over there? A 2, so I write it in here. What do we have left over on this side? A 3, so it's times 3. All right. So check this out. This intersecting part is what we call the GCF, greatest common factor. So what is our greatest common factor, everyone? I know, what is that? 12. 12 is our greatest common factor. Yeah, 3 times 2 times 2. Now, to get the least common multiple, all I have to do is multiply all these prime factors together. Here we go. Yeah, least common multiple. The what? Oh, my bad. Least common multiple. All right, so for the least common multiple, I multiply all of these. So, what was our greatest common factor? 12, and we're left with 2 and 3, right? What is 2 times 3? Times 12, 72 is our least common multiple. Everybody got it? And that's it. Now, let me show you just another way of checking if your least common multiple is correct. Pens down, look up. Check it out. Look up to the screen. What's left over on this side? A 2. What is the opposite number? 36. What is 2 times 36? What's left over on this side? 3. What number is over here? 24. What is 3 times 24? So that's another way of finding the LCM. So make sure you keep note of that. Everybody got it? If you don't want to multiply all this straight, like 2 times 3 times 2 times 2 times 3, then use the shortcut. Does everybody see the shortcut? If you don't want to multiply the LCM like this, 2 times 3 times 2 times 2 times 3, and you just want to use the shortcut, what's left over on this Venn? 2 times the opposite number, 36, that's 72. What's left over on this side? 3 times the opposite number, 24, that's still 72. Everybody got it? All right. Now, I did some animation for this slide just so that, because some people don't understand why we only write 3 times 2 times 2 once in the center. So here we go. Let me show you the animation part. So we find first the prime factors. Here's my Venn. Let me zoom out. This one for 36. Now here it goes. That's why we only write it once, because that's what overlaps for both. Does that make sense? Everybody got it? All right, so with that said, we got that. I want you to do this next one by yourself, so that's the GCF. And we know that we can multiply all these straight to get the LCM, or the shortcut, the opposite number times what's left on the other side, that's 72. And we can do the check also, 24 times 3, that's also 72. You got it? All right, do this one by yourself. Example 2. You don't have to write the words anymore. You already have the instructions. Just write the two numbers, 12 and 18. 12 and 18. It says, what is the greatest common factor of and least common multiple of 12 and 18? Find me those two, please. Go. Okay, so first thing you did, you wrote your first 5 prime. From there, you wrote your 12 on this side, 18 on that side. Found the prime factors of 12, 2 times 6, 2 times 3, or you started with a 3 times 4, that's fine. Same thing over here. So, got your Venn diagram going. So my prime factors for 12 are, let's see, 2 times 2 times 3, and for 18 was 2 times 3 times 3. So what is my GCF? What was my GCF? Did everybody get 6? Okay. Okay, if you made a mistake, let's see what the mistake was. Here we go. It's 2 times 2 times 3. This one was 2 times 3 times 3. What do they have in common? 1, 2, and 1, 3. 1, 2, and 1, 3. There it is. What's left over? A 2. What's left over? A 3. You didn't see the other example that we did? All right, so our GCF is 6, yes? Santi? Yeah, that's fine. Yeah, you get the same. All right, so GCF is 6. What is our LCM? 2 times 18, that's what? 36. And 12 times 3, that's 36. And if you multiply all these together, it's still 36. We got it? Yes? Okay. So any questions with these easy ones? Are we good? You want one more, or should we move on?
No more.
Okay, let's go to the next one then. Example. Wow. Example 4. Copy this one. Example 4 is 60x cubed and 72x to the 5th. Okay, let me zoom in. All right, so here we go. I'm going to write 60x cubed and 72x to the 5th. All right, let's start with the numbers first. We got 2, 3, 5, 7, 11. Okay, so let's start with the number only. Which of those factors divides in there really well? Or 3 times 20? Or 5, right? Yeah, let's go with 5. Very good. 5 times 12. Circle the 5. 12 is 3 times 4. And the 4 is 2 times 2. Factors are 5 times 3 times 2 times 2. So far so good? Let's factor out the x cubed. This is x times x squared. Circle the x. And x squared is x times x. So my factors are x times x times x. Yeah. Yes, I just did it. Okay. Guys, focus, please. Let me go to the next one, and you'll see how it breaks down again, Santi. Here it goes. 72. 72 divided by 5? No. By 3? 3. So that's 24. 24, that's 3 times 8. 8 is 2 times 4. And 4 is 2 times 2. So this is 3 times 3 times 2 times 2 times 2. X to the 5th, once again, is the same as x times x to the 4th. Yes? And circle the x. And this one is the same as x times x to the 3rd. Very good one. We'll get there. Dan, thank you, Voss. Everybody say thank you, Voss.
Thank you, Boss.
X times x squared. And this is x times x. So how many x's do we have over here? 5. 1, 2, 3, 4, 5. Yes. Yes, but first I wanted to show you where they come from. Eventually we're going to move on to, instead of doing all this, we just write this. Do you understand? But I want to make sure that everybody understands where we're getting that from. Yeah. Which one? There you go. Sorry. There it is. All right. Let's write our Venn. Let me move this up a little bit. 1 potato, 2 potatoes. There it is. Nice and straight like mine. Or like Mike. Like mine. All right, here we go. So let's write this. This circle is for the 60x to the third. This one is for 72x to the fifth. So what do we have in common? Do we have a 5 for each side? No. Bless you. Do we have a 3 for each side? Yes. How about 2s? How many of them? 2. So 3, 2, 2. 3, 2, 2. So that goes in the center. 3, 2, and 2. What else do they have in common? 3x. So underline 3x, underline 3x. So that is x times x times x. Tell your neighbor what the GCF is, please. We are. For right now in the Venn, let's do it like this so you can see it factored out. So what's our GCF, everyone? 12x to the third. Everybody got it? What's left over on this circle? A 5, and that's it. What's left over on this circle? A 3, a 2, and the x's. So then 3 times 2 times x times x. So now we're going to find our LCM. Before you multiply everything out, look at it. What's the easiest way of finding your LCM by looking at that? Did everybody see that? 5 times 72x to the fifth. Stop that, Chris V. So what do we get from there? Give it to him later. What is it? 360. And what's x? X to the fifth. Can you multiply 5? No, this is not an exponent. So, did you ever see what we did there? Let's double check to make sure we got it right. This is 12, yes? 3 times 2, that's 6, yes? 6 times 5, that's times 12, 360. X times x times x times x times x, x to the fifth. Or 6x squared times 60x to the third, that's 360x to the fifth. Are we doing? Yes? Yes. No, this is 12. And then 12 times 5, 60 times 6. To find the LCM, all you have to do is multiply all these straight that way. That's it. Or use the shortcut. 5 times that is that. This times that is that. We got it? Okay, let's do another one. Copy this one. Number 5. See if you can do this one by yourself. It's negative 90, a to the fifth, and negative 72, a to the seventh. I mean, a to the second. I'm sorry? Copy that and see if you can do that by yourself. Go. All right, let's see what we got. So I'm going to write my 2, 3, 5, 7, 11. Then I got negative 90, a to the fifth, and negative 72, a to the second. So before we get started, what do we need to factor out of here since it's a negative? Okay. Did anybody factor out a -1 from the beginning? No? All right, I'm going to do that from the beginning. -1 and -1. So now all we have is a positive 90 and a positive 72. Yes? And I'll add that -1 at the end. So therefore, 90. Which one of these divides evenly? 5. 5 times what? 18. 3 times 6. 3 times 2. My factors are -1 times 5 times 3 times 3 times 2. Yes? A to the 4th, A to the 3rd, A to the 2nd, and A. 3, 4, 5. A. All right, this one. We got 3 times 24, 8. Oh, I'm sorry. 3 times 8. 4 times 2. My goodness, sorry. 2 times 4. What is it? And this is 2 times 2. So this is 3 times 3 times 2 times 2 times 2. And this is A times A, so A times A. And it's a -1 at the beginning. So far, so good? I'm going to zoom out so you can see the Venn diagram. We got this one. Hold on, we're almost done. -90, A to the 5th. -72, A to the 2nd. What do both things have in, or both numbers have in common? 2 3s and 1 2. 2 3s and 1 2. How about that negative? And the negative, 2 A's. So it's -1 times 3 times 3 times 2. And then A times A. So my GCF is what? -12A squared. Okay? What's left over on this side? A 5 and A times A times A. What's left over on this side? 2 times 2. Therefore, my LCM, my goodness, LCM, what would be the easiest way to find the LCM? 4 times -90, that is what? -360, A to the 5th. Hands if you got that? Okay. Yeah, you can do that. Play sheet is over here for home play. By the way, it just said, guys, it just says to find the GCF, but I want you to find both, GCF and LCM. Tutoring today. If I don't see you guys tomorrow. Bye. Yeah, the GCF, guys, was -18, not 12. Thank you, Dylan.
I said it too.
-18.
I got 18.
There it is. Thank you. Bye, guys. Have a good one. So this was -18A squared. Okay.